Hello makers, after a long pause, it's very good to be back for another session of IoT Studio. This time I will introduce you to MQTT. MQTT stands for Message Queuing and Telemetry Transport. As the name implies with the word transport, this is a rather low-level protocol. It was designed to power the Internet of Things. It was designed by Andy Stanford Clark and Alan Nipper in 1999. It is today maintained by an open organization called Oasis. It's a standard. MQTT protocol was designed to address the challenges of building the Internet of Things. The first requirement that was taken into account was to be low bandwidth. That's why the protocol was designed as a binary protocol to minimize the overhead that is needed to convey the information between the devices and the server. The second requirement was to be very easy to implement for basic devices connected to the internet. So again, being a binary protocol is much easier to pass for those devices. So this is much easier to implement. The third requirement was to have a minimal overhead. So using HTTP, for example, would have required to resend the context on every request because HTTP is not a connected protocol. MQTT is a connected protocol. And then the context of the session can be reused and doesn't have to be repeated in each packet that is being sent to the network. And the final requirement was to support unreliable network. So quality of service is built directly into the protocol. MQTT protocol relies on three major features. The first feature is publish and subscribe. Publish and subscribe act as a way to decouple producers and consumers. So producers publish to a topic, consumers subscribe to a topic or a set of topics, and they don't have to know each other. The topics act as a mediation layer between the two, and this makes the system built on top of MQTT very flexible. The second feature is that you have quality of service built in, but it's in a flexible way. So you can select on a message per message basis which quality of service you need. So this is very flexible and you can optimize your system thanks to that mechanism. And the third features is that you can build a simple present system based on MQTT. So when a device connects, it can define a message that will be sent when it gets offline, when the connection is lost. So it means that you can have markers. So when the device connects, the session is open and it can send a message to a specific topic, which can be, I'm online now. But it can also at the same time define, if I lose the connection, send this message. And this message could be a message targeting the same topic and saying, I'm offline now. So with that mechanism, you can build a very basic and very simple and efficient presence mechanism. MQTT protocol is relying on three building blocks. The first block is the topics. The topic is the unit of publication for data. So a device has to publish to a topic. A device cannot share information with another device. It has to send data to a topic. There is no other way around. They cannot communicate directly with each other. The second building brick is the subscription. The subscription is a way for a consumer to let the server know the data in which it is interested in. So a consumer will subscribe to a topic or a set of topics. There is wildcards that can be used to let a consumer subscribe to a full set of topic, a full range of topics. And the third building blocks is a session. This is basically what manage device during the lifetime of its connection. The MQTT protocol is very simple. Roughly, it depends on 4 commands. The first command is a connect command. This is used to log into the server and to open the session. The second command is the publish command. This is used by a device to publish a message to a topic. The third command is the subscribe command. It is used by a device or a client or an application to let the server know the list of topics in which it is interested in. And the last command is a disconnect command, which is used for a device, for an application, to cleanly terminate its sessions. I already mentioned several times topics. Topics are identifier for publication channel, basically. What is important to know is that topics are organized in a hierarchy. It means that you can subscribe to a topic, you can subscribe to a set of topics as well. So using wildcard, you can say, I want to subscribe to my topic / star, and I will subscribe to all the publications made on topics under my topics. So now let's talk about quality of service. Quality of service is a configurable behavior that you can choose based on your application requirement. The first level is quality of service 0. It means at most once. It means that you want a message to be received at most once by the recipient. So this is used for a message for metrics, for example, message that can be lost because they will be repeated later on with another value, with the most up-to-date value. So even if you lose 1 or 2 messages down the road, it doesn't matter much. The second quality of service level is quality of service 1, QoS 1. And it means that you want a message to be received at least once. So what this means is that you want the message to be repeated if it's lost down the road, and your recipient has to be prepared to get duplicate of the message because in case of bad network condition, the message will be resent, and then it can be received multiple times by the recipient. So that's why it's at least once. And the third quality of service level is QoS 2, and it means exactly once. So you have mechanism built into the protocol to ensure that a single message will be received once and only once. So it's the most consuming quality of level. So you have to select your requirement based on your exact need so that you use the lowest possible quality of service given your application requirement, because the higher the quality of service, the more overhead it imposes on the protocol, on the server, on the client. As I mentioned, MQTT protocol is a rather low-level protocol. It's a transport. And to make the most of it, you need to design your application protocol on top of the building bricks that are provided by the MQTT protocol. So to give you an example, you need to define your topics hierarchy, your convention, and clients need to know to which topic they will be able to publish, and consumers need to know to which topic or set of topics they will need to subscribe to. Another important point is that you have to design the security of the system. So you need to access control list. Not all clients need to be allowed to subscribe to any topic. So you need to constrain the kind of subscription a typical client is able to perform. So you need access control list for that. And finally, you need to customize the behavior. What will a publication do on the server? Most of the time it's just a broadcast, but sometimes you need more clever stuff. You need to be able to trigger push notifications, for example. You need a lot of specific behavior to be defined. And that way, most of the MQTT servers allow you to write plugins to really customize the server-side behavior and what a publish or what a subscribe will be triggering. So let's talk a bit about security. Security is ensured in the MQTT protocol at several levels. The first level is authentication. You can authenticate your devices with your name and password or with a client-side certificate. The second level of security is TLS encryption. Traffic can be encrypted on the wire. A third level of encryption is possible inside the payload of the message. So you can have an application level encryption which is built on top of the MQTT protocol itself. I mentioned at the beginning that MQTT protocol was designed to power the Internet of Things, machine-to-machine communication. But today, the scope in which MQTT protocol is used is much, much broader than that. So, for example, today it's of course used for the Internet of Things, but it's also used to power games. So in gaming, it's used in application integration. You can build corporate application and let them communicate through the MQTT protocol. It's used to power mobile chat, or it's used to power the real-time web. You have MQTT over WebSocket, for example, and you can connect and control devices through your web browser, for example. As a conclusion, we have seen that the MQTT protocol is lightweight and flexible, but this is because it's a rather low-level protocol. This is a basic building bricks that you can use to build your application protocol, your higher level protocol on top of it. So this is a foundation layer that you can use to build more complex application. So thank you for watching, thank you for listening, and see you in the next IoT Studio session.